In this section, we're going to look at geometric sequences. And geometric sequences are sequences that you obtain from taking the first term in the sequence times a number, and then you get the second number in the sequence, and then take that times the same number to get the third number, etc. So this number, we denote it with r, and it's called the common ratio of the sequence. So maybe r is 4, so you would take a sub 1 times 4, then that result times 4, etc. So in general, you get the next term in the sequence by taking the previous term times r. That's what this statement is saying. So r is called the common ratio of the sequence. I already said that, didn't I? The nth term of the sequence in general, then, we can find the nth term by taking previous terms times r. If we know the first term, we would take it times r to the n minus 1. So notice in the pattern here, right, the second term, you take it just times 1r, the third term times r twice, etc. Okay, I should mention, notice the notes are already filled out. That's because I already had recorded this and I lost my video, so I have to redo it. So I'm going to just walk through it because I don't have a printer to reprint the paper. So let's see. In this example, we're given that a sub 1 is equal to 2, r is equal to 3. Find the first 5 terms of the sequence, and the 30th term, and the nth term. So, of course, the first term is given, that's 2. Then you take that times 3 to get the second term, so 6. And then you take a sub 2 times 3 to get 18. But, of course, you could also denote that as 2 times 3 squared. A sub 4 would be 18 times 3, 54. A sub 5, 54 times 3 is 162, and so forth. And if you want the 30th term, we don't want to find all of these terms, so we'll just go back and use the first term, 2 times 3 to the 29th. And this is very large, so that's saying here, so you can just leave it like that. If it's really large, it's like, I think it had a times 10 to the 16th in the answer, if I remember right. So don't have to write that all out if it's a really crazy number. A sub n then would be, of course, the formula is a sub 1 times r to the n minus 1. So 2 times 3 to the n minus 1 would be the formula for a sub n. So this is just asking for a formula in terms of n when it asks for the nth term. In the next problem, we're given the terms of the sequence, we're asked to find a sub 1 and r. A sub 1 is obviously 1, that's always the first term. And it's pretty easy to see that we would keep multiplying by a half to get subsequent terms. But if you're not sure what r is, you can, of course, solve for r just by saying, well, okay, if I take, and you could pick any 2 terms in the sequence. If I use 1 and 1/2 or 1/2 and 1/4, that's what I used to when I first did the video. 1/2 times r equals 1/4, so just divide both sides by a half. R is 1/4 divided by 1/2, or 1/4 times 2, which is 1/2. In this problem, I think it's pretty easy to see the pattern without doing that, but if you're ever not sure, that's something you could use. Of course, in this case, you would do 1/2 divided by 1, which is 1/2 if you use the first 2, etc. You'd always get the same result, whichever 2 consecutive terms you use. Well, I guess that's all I have to say about that. Let's go on to the next page. So another problem here, a sub 1, of course, is 2, and then we're multiplying times -5. Notice how the terms alternate in sign, so r is negative in this case. And I don't think I mentioned that, but r can be positive or negative. In the next problem, oh, I should point out, so if we were going to use the division here, we would do -10 divided by 2, or 50 divided by negative 10, right? We always get negative 5. In the next problem, we have the first 3 terms. We're told it's geometric, but you can see that it is, even if that information wasn't given. 5 times 3 is 15, 15 times 3 is 45, etc. So just like in the last section we did arithmetic sequences, if you're told a sequence is geometric, even if you're only given these 2 terms, you know you can figure out the next term because you know it's geometric, right? 15 divided by 5 would be 3, that's r. And so 15 times 3, you could get the next term. But again, you have to be told it's geometric in order to do that if you're only given 2 terms. Obviously 2 terms isn't enough to see a pattern unless you're given more information. Okay, so back to the problem. The 8th term would be a sub 1 is 5 times 3 to the 7th. And again, we can just leave it like that. 3 to the 7th is, I guess this one's not so big, 2,187. So 10,935. But it'd be fine if you left it like this. That shows you can do the problem. All right, one more problem, and then that I have a separate video for beyond this problem. So the third term of a geometric series is 63 over 4, and the 6th term is 1,701 over 32. Find the 20th term. Okay, so we know a sub 3 and we know a sub 6. And we know that we would need to take a sub 3 times r 3 times to get to a sub 6. So that's what I wrote here. A sub 6 would be a sub 3 times r cubed. Plug in those values that we know for a sub 6 and a sub 3 and solve for r cubed. So we divide both sides by 63/4, which means multiply times 4/63. And we can do some canceling here. 4 goes into 32 8 times. 63 goes into 1701 27 times. So that implies r cubed is 27 over 8. Take the cube root of both sides, so r is 3/2. And then we can find the 20th term by using either of the 2 terms that were given. I used a sub 3 here, and so we would need to multiply times r to the 17th. So these should always add up to the 20, the subscript and the exponent, then you know you've got the right number of r's. So 63/4 times 3/2 to the 17th. If you use a sub 20 to base this off of, I'm sorry, a sub 6 I should say, to get a sub 20, then you'd multiply times r to the 14th, so 6 plus 14 is 20. So that's 1701 over 32 times 3/2 to the 14th. And if you use your calculator to get the answers here, you will get the same answer for these. I'm not going to do that though. You can do that on your own if you're interested in that. Okay, that's it for this video. The next one is actually already done. So